Welcome to the next topic in this course, welding. Welding is a very important topic in manufacturing. So, here we try to look into the science of joining. You know very well that many large structures cannot be constructed either by casting process as well as by forging process. Now, what is the next alternative? The next alternative is you make small pieces and try to join those small pieces. So, welding is a process wherein which it tries to take care of all these things. So, if you want to construct a large plane, if you want to construct a bridge, a test rig, a rocket holding device, or if you go to the other extreme end, the artifacts what you see in the showcase of your house, very small, very flimsy, but it has multiple small parts joined together by a soldering process or a brazing process, small, and welding also gives a lead towards additive manufacturing, which we will try to cover later in this course. So, welding is a very important process. The content of this lecture is going to be an introduction, a small history. I always try to cover a small history because you would like to know how did this evolve. Today we are in a very advanced stage. If you look at IC chip, where in which a small legs are joined, very small, very nano, it is joined. Right. So, if you understand the history, you will also see how did the history grow and where are we today. So, history, then the classification of welding process. It is not only one process, like in casting we saw many, in forging we saw many, in welding also we see many. Then fusion welding, solid state welding, gas welding, these are all falls under the classification, applications, and the welding process also has lot of inborn defects. We will see few of them. Then once the defect happens, how do you inspect and what are the inspection methods we use to check the defects. So, we will see that, and finally, we will try to have a recap of welding process itself. Ship manufacturing involves welding, and if you look at it, pretty interesting. Submarine, when they have some small rework to be done on the base or ship, it has to be done, then the same welding has to happen underwater. Look at the challenge. Underwater also they do welding, open atmosphere they do welding, on tall structures they do welding. The Statue of Integrity, which is there in India, many of the rods are joined together by welding. Howrah Bridge, welding is involved. So, welding is a very interesting process and important process. What is welding? Welding means it is joining of metallic components. When we have metallic, we generally try to apply heat with or without pressure or filler material. What we are trying to say is welding is metal to metal joining. The first point, when two metals have to be joined. So, now we have to look into how will this metal go and join with the other metal. One, you can apply enormous pressure, it will join, which is elastic, plastic, you enter into plastic zone and then you apply. The pressure can be applied and kept for a longer time, or the pressure can be done by impact load for a short instance, pressure joining. If I cannot generate so much of pressure, then the other way around is I try to apply heat and I try to melt. When I melt, the material gets softened. It will not go to the casting stage, completely making a bucket of molten metal. Here at the edge, there will be softening, little bit of going down or going up towards the melting point, it will be there, and then we try to join. When we have to try to join, you can again apply pressure, or it can be joining without pressure. So, that is what we talk about. Friends, the welding process is also common for polymer joining also, though in this course we will not cover polymer joining, but polymer to polymer joining also happens by a process called welding. Only the difference between metallic component and polymer is the temperature which is involved. And you should also understand thermosets cannot be joined. So, it will be either thermoplast or it will be elastomer joining. Okay. So, joining is not only for metallic, it is also for non-metallic. Joins metallic components using heat with or without pressure, and here I till now said it is only by applying pressure or by applying temperature. But now what I am trying to introduce one more component is I put an intermediate phase in between and then I try to join. So, the function of the intermediate phase, the black whatever I have it here, the pen. So, it is an intermediate phase. If you see like this, it is an intermediate phase. The intermediate phase can be another material. That material is called as filler material. So, the advantage here is the filler material. So, you have one metal, you have another metal, you have filler here. So, now this is metal 1, 2, it can be same metal or it can be different metal. Then it has a filler in between. This filler material alone melts and then it tries to join both the fellows. So, for example, I have two hands, assume that I am the filler material. I am there, I melt, I fill the gap and I attach myself with the two metals. It can be same metal or it can be different metal. For example, it can be metal 1, metal 2 or it can be metal 1 and metal 1. So, that means to say homogeneous material, it can be heterogeneous material, or I will put it in simpler fashion, it is similar material or dissimilar material. Okay. So, here the filler you can always choose what will be the melting point. When we do soldering, the melting point is extremely low, as just above room temperature. When you talk about the heavy metal welding, the temperatures go very high, depending upon the melting point of the filler, right. The heat can be generated through chemical reaction, electric arc, electric resistance, friction or light energy. So, now I said the heat will be applied. Now, how do you apply heat? I can apply heat through a flame. When I apply through a flame, what happens? The flame diameter is very large. So, now because when it is large, what happens? Then you have to use a large amount of filler material, or there will be more amount of melting happening at the joining portion. So, now what we do is we change the flame to a electric arc which is focused. Now, from that, if I want to have much more focus, I try to have a plasma, a photon, that is light energy, right. So, I apply electric arc, electric resistance and light. And it is not only this, because if you try to apply electric arc, flame and light, it is going to be energy consuming. So, now I also can generate heat by friction. Friction I can generate heat. Now, between the two surfaces, if I rub, there is a heat which is generated, and when the heat is sufficient enough for these two metals to join, then friction also can be done. Today we talk about friction stir welding. What we do is we have two metals to be joined and there is a rod or a tool which goes in between and it tries to create friction between the two materials. So, friction is the other way around. The difference between arc and resistance is resistance I can apply two pieces and I can apply a high current. So, now the current passes through it and there it is the resistance, Joule heating effect, the joining can happen. This is electric resistance. When I have two electrodes, I heat, there will be a discharge happening and through this discharge there will be melting, electric arc. Finally, chemical reaction. When I try to take two different chemical compounds and mix it together, there can be two types of reaction. One is exothermic reaction, the second one is endothermic reaction. When I have exothermic reaction, exothermic reaction, then the exothermic tries to heat the metal which is in the vicinity. So, that heat takes it to the melting and joining can happen. The railway tracks are done by chemical reaction. So, these are the possible ways you can try to apply heat. So, when I apply heat, when I apply pressure or both between two metals, I can join. So, that is what is told here. The joint may be welded is a permanent in nature. So, why am I putting this permanent point here is because whatever joining happens, it is permanent. It is not like your nut and bolt. Finally, if you see, I want to join two pieces, three pieces. I can always drill a hole, put a bolt and a nut and join. Possible, right? When you are trying to do many of the assembly in automobile industry or in cycle, you will see lot of temporary assembly is done. Nut and bolt will be used. But when we use welding, it is called as permanent joining. Permanent joint needs a large amount of force to break the joints. In some welding process, a filler, that is what I said, intermediate metal is used to facilitate the coalescence. The assembly of parts that are joined by welding is called as weldment. So, here you can see there is an electrode, this is an electrode which is there, this is a filler material. This is a filler material which goes, this is metal 1 and this is metal 2 which I was talking. And here there is an circuit which is there. So, there is a flow of electrons happens like electric arc, there is a flow which melts the filler and the material is getting filled between this region. This is how we try to do ship, rocket and other large assemblies. So, there are majorly two different types of welding. So, autogenous welding and heterogeneous welding. In autogenous welding, similar metals without a filler material is joined by applying pressure electric resistance welding. So, is it clear? So, we are trying to join metal 1 and metal 1, mild steel, copper, copper, titanium, titanium, stainless steel, right. Similar metals are joined, but without adding a filler. I do not add a third party inside. It is without that I try to apply heat and then join, or I try to apply pressure and then join. While homogeneous welding uses a filler material with the same composition as the parental material. Is that clear? So, autogenous welding, no filler. Homogeneous welding, same composition, that means to say I use metal 1 and the filler is also metal 1. For example, I take copper and then I use a filler also copper. I use aluminium, titanium and titanium, stainless steel and stainless steel. I am giving an example, right. So, while homogeneous welding uses a filler with the same composition as a parental material. Low carbon steel weld with low carbon rods. The filler, if you see in the previous one, the filler is a rod. So, the filler can be either a rod or it can be a wire. When it is wire, it is continuous in nature. When it is rod, it is discrete. What is discrete? As and when the stick, see, when you try to have an arc, there will be a melting phenomena happening. The melting phenomena will allow the filler to be filled in intermediate between the two metal joining. So, once that, it is like a pencil, you sharpen, the length keeps reducing. Same way the filler rod also, it keeps reducing. So, after the filler rod is consumed to a certain height, you replace it. It can be few minutes, it can be few tens of minutes, right. So, the filler gets. So, if you want to have a continuous welding, then we start using a wire. Heterogeneous welding. It involves a filler metal with a low melting point. Heterogeneous, a filler material with a low melting point than the parent metal, and is used for metals like zinc, brass, aluminium, which are prone for oxidation. So, heterogeneous, the important points are: the filler is used, the filler need not be the same composition as the parental material. It is used in zinc, brass, aluminium, because aluminium, when you heat it to a certain temperature, immediately oxidation happens. Because of that, what we do is, we do not try to melt the parental material, but only try to play with the filler material. Brazing, soldering are all examples of heterogeneous material. So, now I am sure you will be able to see the difference between autogeneous, homogeneous and heterogeneous. Autogeneous means I do not try to use a filler. Homogeneous, I use a filler of the same composition of the metals which I have to join. Heterogeneous, I use a different composition to join. Why do I do? Because I do not want to change the parental properties of both the metals. Let us get into history and see how did this welding happen, or when did this happen. Its origin can be traced to ancient times around about 1000 BC. Egyptians and the others in the eastern Mediterranean area learnt to accomplish forged welding. That means to say, they had two different materials, they placed one above each other or besides each other, and they applied a huge pressure. What is the pressure? See, those days there was no machine tool, there was no machine. So, they used to do it manually, or what they used to do is, they always try to do an impact load. Impact load means they will try to have a heavy wheel, they will rotate the wheel, and once the rope tries to take a stone or something, it goes to a higher distance, from there they instantly release. So, drop forging was exhaustively used, or they used to beat it, right, beat it and then forge it. They used to make weapons, tools and other implements. It was not until 18th century that the technological foundation of modern welding were established. It was primitively done, and those days they were all the time interested either in artifact side or in terms of artillery side. They were always trying to make weapons, tools, for whatever reasons they were trying to use. Two important discoveries were made, attributed to English scientist Sir Humphrey Davy. One is electric arc, and then the other one was acetylene gas. So, these two things brought in a big difference in welding process. Bernard Dawes' invention seems to have been limited to carbon arc welding, with enhancement to the metal arc welding process being made in England and Sweden starting around about 19th century. Between 1885 to 1900, several forms of resistance welding were developed by Thomson. Why? Because the electric energy generation was slowly they were trying to have a hold on it. During the 1980s, hydrogen and other natural gas were mixed with oxygen for welding. That is what I said, oxyacetylene flames were used, but the oxyacetylene flames achieved significant higher temperature. So, there are two things which happened parallelly. One is electricity, electric and resistance and other things was going on, and the other way is people started using gas. They started mixing gas, understanding the flame characteristics, taking it to a higher temperature. They were now looking into whether we can go for homogeneous or heterogeneous welding. So, the major evolution or development happened after 1880, and maximum we could reach by 1950. After that, we started doing delta X improvement in the welding process, and lot of hybrid process was also evolved. So, this is a small history. So, I thought I should bring it to you, so you can understand it. So, now let us see what are all the major advantages of welding. By this time, you would have yourself perceived some of the joining process which is around you. So, welding can join large number of both similar and dissimilar metals alloys. A good weld is as strong as the base material. Please do not think that when I try to fill a material, I will not get the same strength as the parental. No, you will get the same strength, or sometimes you can get much higher. Many a times when we do a welding test like UTM, universal tensile testing you do, you will see that the weld will be exactly placed as it, the metal gets fractured. The portable welding equipments are also available. So, that means to say on site preparation. This a typical example is any construction industry, if you see, for example, house construction, heavy engineering like making a ship, a plane, a boat, right, heavy engineering, and then you there you see the welding equipment is transportable. So, moment it is transportable, then it gives you much bigger advantage. For example, train, engine, right, you always do lot of welding there. So, portable welding equipments are available. So, the source for joining is possible. When you use heat, pressure means again you will have a problem, but only heat portable came into existence. That means to say you can think of electric, or you can think of gas, or you can think of light, right, or as the heat source for joining. Then welding permits considerable freedom in design. For example, you have a structure like this. There are pipes, right. So, you want all these pipes to be joined. Maybe there is a flow from this portion, there is an exhaust, there is one more flow happening here. Assuming here there is a combustion happening. So, you see here there can be a different design, and they can be from multiple directions, like it can be something like this. So, one from this direction, one in this direction, one in this direction, they all get joined at the base. So, welding permits considerable freedom in design, low manufacturing cost and reduced labor content of production. So, that is why welding is now trying to be used exhaustively. Welding results in a good saving of material and maximize homogeneity. Welding provides a permanent joint. Welded parts become a single entity. Welding is not restricted to the factory environment. It can be accomplished in the field. So, this point and this point are linked. The portability plays a very important role. Anywhere you can start using it. So, these are the advantages. For example, you cannot take a rolling machine and then start producing at site. It is difficult, because there it is only pressure which is involved, and that has to be in a machine environment. So, what are the limitations? The limitations are, it results in residual stress and distortion in the workpiece. Why? Because there is a component called heat. The heat is linked with time. If you instantly release the heat, the time is too short. This leads to residual stress. The residual stress can be of two types. One, it can be mechanical in nature. The other, it can be thermal in nature. Right? Thermal in nature also leads to both tensile and compressive. Mechanical also leads to tensile and compressive. It can be like this. So, when I bend, it is mechanical. The outer portion undergoes tensile, the inner portion undergoes compression. The same way, residual stress also what happens when the heat is instantly released. So, the metal can be pulled and joined, or it can be, when it is pulled and joined in the top, it is tensile, or you can say compression. So, then the bottom undergoes tensile. So, the residual stresses are prone to happen because we are trying to use heat. Distortion is also coming into existence. Why heat? Because the heat comes from gas flame, you can use it for joining, or you can use electric, where in which you have two things, one is arc, the other one is resistance, and here you can try to have light as photon. So, because of the three, there is a heat with respect to time, and so that leads to distortion. The distortion leads to residual stress. This is one of the biggest limitation of welding process. So, sometimes you can see a heavy plate welded and later it will warp, it will bend. So, that is because of welding difficulty. The welded joints can also suffer from some quality defects such that are difficult to detect. So, what happens is when there is a melting and flowing of metal between the two plates to be joined, there can be very small types of pores, right, between this. This is the filler material. This is filler, this is the metal. So, here when you try to pour, there can be oxygen which is there, or while pouring there can be difficulty while solidification also these pores can happen, which we saw in casting. So, these are some of the small defects which are extremely difficult to be detected by any of the non-destructive testing methods. Until and unless you slice it, put it under a microscope and zoom it and see, you can't see such small defects. So, that is what we try to say. So, certain defects are prone to happen, which is very difficult for us to see. So, that leads to poor service performance. The defects can reduce the strength of the joining because of the heat which is involved. The strength of the parental material can go down. While heat is involved, the metallurgical change also happens. These 2 points are linked. Okay. The weld produces harmful radiation, fumes and spatter. While joining, if you see here also, you see there is a spatter which is happening, this as well as this. You see that something like a Diwali pataka, you see, that is called a spatter. So, spatter is blast of liquid which is getting spread. So, that is fumes, radiations and spatter can be there. Jigs and fixtures are required to hold and position the part for welding. So, while welding, what happens, sometimes while welding itself there can be a distortion happening. So, there can be, because of the liquid which is getting filled, there can be a buoyance force which will try to move the plates, the parental material to be joined. So, this has to be avoided. So, what do? We try to place it in a jig, right, and a fixture. Fixture is to hold, jig is to guide the tool. So, we need jigs and fixtures such that it can be done. Sometimes it needs a skilled worker to do the operation. For example, underwater welding, it always needs a skilled person. A normal man cannot do it. And when we are trying to do bracing, soldering, where you are trying to join very thin wires, thin sheets, again you need to have a skilled person. So, that is what are the limitations. So, by and large the limitation goes around heat. That is it. Heat leading to residual stress, heat leading to defects, heat trying to change the microstructure. Because of the change in microstructure, the strength goes down. Because of the heat, the radiation, fumes and sputter happens. So, because of the heat, you need to hold it properly. So, all these things are related to it. And welding, if you want to become a highly skilled welder, there are several trade tests and certifying agency. What we do in the engineering college and we practice, it is only an exposure. If you want to become an expert, there are certifying agencies, you have to undergo several tests where they check the theory as well as practical to make you a skilled worker. Okay. Where are the applications? Pressure vessels, I did not touch about this topic. Pressure vessels are boilers, right. You can see where there is steam turbine is connected, electricity to be produced, water is heated, the heated steam is pushed into, and this pushed hits the turbine rotates, then there is attached to a generator, you get it. So, pressure vessels, right. Then the other thing is you can also see for storage purpose, storage of fuel, grains, For example, I have several tons of wheat which has to be stored. What do? I make something like a big vessel, and this big vessel I fill up with grains. I protect it from the environment. So, you need a huge container. So, that container cannot be done by forging process or by rolling process. It will be done piecemeal and it will be attached. Bridges and buildings are the other big applications which you can see. Then you can see aircrafts, spacecrafts and shipbuilding are part of it. So, here building is construction civil, here it is shipbuilding. Then in automobile, where you have different shapes. So, automobile and electronic components, we use lot of welding process. Defense transportation tankers use welding process. Then welded pipes, chains and LPG cylinders, they also use welding. The steel furniture, doors, refrigerator, oven, etc., which is a household item, there also welding is used. The only difference between the high end and the low end, that means to say pressure vessel and the refrigerator, is the amount of heat which is involved and the technique what we use. So, all places we try to use welding, and here I am trying to demonstrate and show how robo can be used, because robo, today we talk about cobots, a collaborative robo where human and robo can work together. What a man was doing, now a robo will do the same operation and you can try to get the best out of it. So, you can see here critical portions where man is involved, where pipe joining is done by robo, and it is not by single robo, and here you have multiple robos. So, parallelly two things can be done. This is what I was trying to talk about chemical. We in the railway track, you would fill up with some chemical, expose it to heat, explosive reaction. So, there will be heating there, melting there and joining happens between the rails. So, everywhere you look into, there is a component called as power density. What is the energy I apply per unit area such that the welding process can happen, right? It can be heat, it can be through forge, or it can be a combination, whatever it is. For metallurgical reasons, melting the metal with minimum energy is desirable. Why? Because there is always a microstructural change. Microstructural change leads to phase change, right? This phase change in turn dictates the mechanical property. So, that is why we always try to use minimum energy in doing the welding. So, melting the metal with minimum energy is desirable, and high power density are generally preferred. What is high power density? Power applied by unit area. So, laser has the highest power density in heat as compared to that of electrical and gas flame. The power is very high. The power density can be computed as the power required or power entering the surface divided by the corresponding surface area. So, the power density is generally reported as watt, because power is in watts, joules or watt, divided by area, millimeter square. So, power is entering the surface is P, the surface area over which the energy is entering is A. So, you can see here oxyacetylene flame, what is the power density, then arc welding, this electric which I said is around about 50, resistance welding is around about 1000. Resistance welding is what? You join two metals and then you apply current passes through it, Joule heating effect, resistance welding. You see laser, it is around about 9000, and you see electron beam. Electron beam and arc welding are different, right? Arc welding has a lower power density. Generally, what we do in construction industry and all, we use arc welding processes. And laser is used in a company where the component size is small, or you need a precise control, we use laser beam, where the power density is around about 9000 watt per millimeter square. Electron beam is used for joining of electronic materials, thin sheets or thin electrodes or thin legs they use. Here it is very high, it is done in a vacuum and it is very high. So, you need to know this. Which one do I choose such that I can try to bring the efficiency in the welding process. So, then that the power density leads to heat balance. We will see fusion welding next, but heat balance now you can try to take in welding, just keep that in mind. The quantity of heat required to melt a given volume of metal depends on, I have a lump, this lump has to be melt such that it flows inside, or it has two metals, it joins. So, all I have to know is what is the volume I have to melt such that these two fellows can join. So, there what we do is the heat to raise the temperature of the solid metal to the melting point, which depends on the metal's volumetric specific heat. At what heat the change of phase happens. Then the melting point of the metal, then the heat to transform the metal from solid to liquid phase at the melting point, which depends on metal heat of fusion. So, approximately the quantity of heat can be estimated by this equation, which is unit energy required for melting, right. That is the required amount of heat to melt a unit volume of metal starting from room temperature, which is generally reported in joule per volume, I said millimeter cube, right. Then which is equal to K times, K is a constant which takes a value of 3.33 into 10 to the power 6. This is an empirical value. They did lot of tests and then they have found out what is the K value there into T square. What is Tm square? Is the melting point of the metal on an absolute temperature scale, which is in degree Kelvin, is reported. So, generally what we say is U is directly proportional to T square melting point, but you have to remove the proportionality. So, we try to introduce a terminology called as K, through which what we try to get is we try to find out the unit energy required for melting. So, for various metals, what are all the melting temperature? We have just reported aluminum alloy, which is the round about 930. When you try to go towards brass and all, it is round about 1160. Nickel is 1720 Kelvin. Titanium is around about 2070 Kelvin. Now, let us try to look into the classification of welding process. Welding has several classifications. One is gas welding, depending upon the heat source, gas welding, then it is resistance welding, then it is arc welding, which is exhaustively used, then it is high beam welding, then solid state welding. There are 5 categories. Gas welding, where the heat source is extracted from a gas. So, we can have oxyacetylene, air acetylene, oxyhydrogen as the heat source, through which you generate a heat which tries to melt the material. Resistance welding is we try to create a resistance between the two metals to be joined. It can be butt joint, spot joint, seam joint and projection joint. Projection joint are, there will be projections you can join together by resistance. So, projection joints. Arc welding can be carbon arc, metal arc, plasma, gas metal arc, gas tungsten arc, cold metal transfer welding process. They all fall under arc welding process. The high is, I said, laser and electron beam, which we already discussed little bit in the past. Then when I try to talk about solid state welding process, in solid state welding process you can have friction, ultrasonic. Friction is generating heat, right, by friction. Ultrasonic is you try to again agitate it at a very high temperature, 21 kilohertz with a small displacement to get. Then diffusion, explosive, magnetic impelled arc butt welding. So, that is also there, because when you have a liquid source, molten metal liquid source, you apply magnetic field, then there is a Lorentz force which is created and there will be throw of metal. So, magnetic field is also playing a very important role. Induction pressure welding process, then flash butt welding process, magnetic pulse welding, cold welding process. So, these are some of the solid state welding process which are there. So, when I talk about welding classification, already I have said autogenous, homogeneous and heterogeneous. The other classification is this. Thank you very much.